Hi, in this lesson we're going to deal a bit more with CMake. We need to configure our dependencies. We will start with writing find package, and inside we will write Vulkan and then required. If you have installed the Vulkan SDK correctly, CMake will be able to locate Vulkan. We want our executable to then link to the Vulkan package. So we write out target link libraries, and then we write out our executable name. Then private, and finally Vulkan : Vulkan. When I save, Visual Studio will auto-reload the project. And if everything is done correctly, I can go into the main file and include vulkan/vulkan.h header file. And it should also build without any issues. I will clear it out for now though. Next, we want to configure CMake to automatically collect and build any files that we put into the source directory. So we write out file glob recurse. Then I name a variable that will contain the list of files. I will add the option that the configuration step depends on those files. And finally, I write out the glob pattern. Inside the string, I expand the current CMake directory variable. Then I pass the source path and star.cpp to get any CPP files inside the source directory. I duplicate the line and change the extension to H. And finally, I replace this main here with the expansion of our list variable. I will test once more that the build works. This is usually a good practice when you change up some configurations. Next, since we also will use headers, we want the source directory to be what is called a root path. This means that you don't write include source/main.h. You write out include main.h directly. This is done by setting include directories for our target. We pass private include directory to be our source folder. One more thing is that we want to set the C++ standard. We can do this by setting the target compile features and write out cxxstd20. Using C++20, we can use the file system header, for example. So I test this out. Now we need a few more dependencies. We will get those from GitHub, so we will need to include one CMake extension module. This module is called fetch content. This will allow us to write out two new commands: fetch content declare, which is used to describe our package. We will now include GOM, so I give it a name. Then we will need to write git repository and paste the link to Git. This can be found in the GitHub page. You can also find the link to this in the course resources. Otherwise, the link can be copied from the green drop-down here. I can then return to CMake and paste it. We will now need a git tag. The tag is a concrete version. I encourage you to use the one that I am using for consistency, but you can find the tags on a GitHub page, otherwise as you see me copy it here. And finally, we want to just copy the version and not the whole Git history. We're just going to use it as a dependency, so I enable the git shallow option. Now, this command just describes the package. So we need one more command called fetch content make available. We will just pass in the GLM name that we gave earlier. And again, just like with Vulkan, we need to link the library. So I duplicate this line here, where we link Vulkan, and write out GOM. I save CMake, and this time it will take some time to configure the project. It needs to download the GOM library. If we now go to main, you will be able to include the GOM header file. I test it out quickly and return back to CMake. The last thing for this video will be to get GOFW. I go back to the GitHub page and in the search bar I type out GOFW. We need this GOFW/GOFW repo here. And I do the same thing we did for GOM. copy the link, duplicate these two commands, and replace the link and names to match the GeoFW's needs. And also don't forget the tag. Lastly, we need to link GeoFW to our project. So we also duplicate this line here and change GeoM to GeoFW. I skip ahead since it takes a bit more time to download the GeoFW library. And now if we try to include GeoFW, we can. This is how we will structure our project and manage our dependencies in the future.